Okay, so we were about to calculate the predictive performance measures for the regression tree model first, right? That is done by the function accuracy. So as you start typing, you should see the name of the function to show up. And the function takes two parameters. First is the name of my variable that has predictions. So predicted prices for the regression tree. Okay. And the second, what are the actual prices? And the actual obviously are sitting in the data set Corolla. So therefore we have to say Corolla $price. So I'm sending this function two parameters, which prices are predicted and which prices are the actual. And when I run this line, there you can see that I have right here at the bottom of the screen, I have the output. So the output says that we discussed three measures, right? It actually calculates more than three measures, but the ones that we discussed: mean absolute error, that's the average absolute value of the errors, 1154. The next one that we discussed was MSE. While it doesn't report MSE, it reports R. MSE. R stands for root. So that means that, let me bring up the screen. Yeah, that means that instead of calculating the MSE as the sum, as the average of the squared errors, when you add R in front of that root, that means that after you calculate the average squared error, you take the square root from this expression. But you understand that if MSE goes up, then RMSE, square root from MSE, also goes up. So therefore, from that standpoint, both measures can be used just the same. So square root from the MSE is 1529 and MAPE 10.31. Now this one actually has the interpretation. Okay, so well, all of them have interpretation on average. So let's talk about MAE first, mean absolute error. What it basically means that on average, my predicted price is $1,154 off from my actual price. It can be on the on the high side or on the low side. So I can underpredict or overpredict. It doesn't tell me. Okay, so on average, I'm wrong by $1,154. RMSE is much more difficult to interpret because it's kind of the same thing as the standard deviation. Okay, so if I can interpret my errors as data points, then if I calculate the average error and I calculate the RMSE, it's going to be, roughly speaking, an analog of the standard deviation. So sigma for my errors is $1,529. MAPE, the interpretation, reminder, MAPE is mean absolute percent error. Okay, and we calculate that as an average percentage that my errors represent out of the actual value, right? So the interpretation of this number is that on average I'm making 10.3% error. So each time when I predict the price, I'm off from the actual by about 10.3%. So these are the accuracy measures for my regression tree model. So again, coming back to our discussion, is that a lot? Is it not so much? Well, I don't know. I don't have a frame of reference, really. Okay, what am I comparing it against? Ideally, there should be zeros. Well, they're not. They're never going to be zeros. So in order for me to make more sense out of these numbers, what I'm going to do is actually reproduce my other model from the video about the simple linear regression, and I'm going to compare these two models against each other. So for that, here I'm going to type, first I have to create the model, right? So I'm going to say train simple linear regression model. Okay, so price, how do I call it? Predicted. No, the previous model was crawler prices regression tree model. So now I'm gonna have crawler prices price underscore simple underscore linear regression model. So long name with underscores. Corolla price simple linear regression model. Okay. And if you remember from the previous video, the way how I train this model is LM. LM stands for linear model. And first I have to specify what my model is. Okay, so that would be price tilde. Since this is simple, that means that I have only one predictor, and that would be mileage, right? We discussed that mileage is probably the strongest predictor out of them all. Okay, so this is my model. Because there is only one predictor, I call it simple. And of course I have to say that data that I'm going to use is the same, Corolla. Okay, so when I run this line, well, my model is here. Okay, so now I can use the model in order to predict prices based on just the mileage and nothing else. Okay, so here I'm going to put the comment saying calculate predicted prices using simple linear regression model, just like that. So I called previous prediction predicted underscore prices underscore regression tree. So here I'm gonna say predicted prices simple underscore linear underscore regression. Okay, so it's different set of predicted prices, different model, different predictions, right? So I'm gonna use the same function predict, and just like before for the function predict, just like over here, I have to send what is my model and what is my data. So my model is, I just trained it, it's called Corolla price simple linear regression model right here. Okay, and my data, let me move that a little bit, and my data that I'm using is Corolla. There you go. So now I run my model, and well, I got my predictions, right, using different model. Let me go ahead and take a look at the predictions, just out of curiosity. There should be 1,000 of them, right? 1,000 data points, yeah, 1,000. But now you can see the difference between that model and my previous one, which I just ran. That would be regression tree. Is regression tree, should have it somewhere here, right? Plots, yeah, regression tree. It essentially, this model gives me only 1, 2, 3, 4, 5, 6 different predicted prices for all vehicles. It's one of these predicted prices. That's their prediction, right? That's the prediction that I can get with my simple linear regression tree. Okay, this time around, because all cars have different mileages, all predicted prices, you can scroll through them, they will all be different, because the predictions are calculated based on the formula that relates price with the mileage. Well, the question is, of course, is that a better model than the regression tree? Well, let's see. So just like I did before, I'm going to say I will calculate predictive performance measures. For simple linear regression model. Okay, so I'm going to use the function accuracy, just like I did before. And again, I'm sending the predictions and the actual prices. My predictions are right here: predicted prices, simple linear regression. Predicted prices, simple linear regression. Okay, and the actual are in the file Corolla hold price. Okay, so now I'm gonna run this, and yeah, here are my measures. So mean absolute error is 2282. Let's compare that with the one that we had before. I'm going to pull up all the data here. So the mean absolute error for the regression tree was 1154. So I can see that regression tree is better in predicting the corolla price than the simple linear regression based on just mileage. MAE is lower. What about RMSE, root mean squared error? 1529 for regression tree and 3007 for simple linear regression. So again, my regression tree gives me lower value for the mean squared error. So it's better. Predicting the price is closer. And MAPE, if I remember correctly, they were 10.3% for the regression tree. So my predicted prices were within, on average, of course, all of these are averages, right? On average, were within 10.3% of the actual prices. And for the simple linear regression, they are within 19.3%. So once again, the simple linear regression is actually a worse model than the regression tree, which we can see right here. So that's how I can calculate the accuracy of regression models that predict for me the numerical target. That's how I can essentially use these performance measures, MAE, RMSE, and MAPE, in order to compare them against each other. Again, I'm shooting for lower values of my performance measures. Ideally 0, but it's never realistic. Okay. All right. So how do we improve the performance of regression, of linear regression? Well, in this case, what we did basically was we called it simple linear regression for the reason, right? Here, when we train the model, our model essentially says that the price depends only on the mileage, and that's it. While we know that in actuality, price depends on a lot of different things. Mileage may be the best single predictor, but it's not the only predictor. So what we can do with the model is we can add more variables, thereby making the model more detailed. And as the model gets more detailed, it can follow the data more closely. So therefore, my hope is if I add to the model more predictors, its accuracy will be higher. And that's what I'm going to take a look at in the next video.